Hello, welcome to week 8 of SOL preparation. Today we're talking about surface area and volume. Another way we could reformat this or talk about it in a different way is really we're just going to teach you how to use your formula sheet. This right here is actually part of the front side of your formula sheet that you will get on the SOL. I'm going to start by just telling you what we're looking at here. Right here, it's flat, it's got 3 sides, this is a triangle. 4 sides with 4 right angles. All the sides are the same. This is a square. Again, 4 sides, 4 right angles, but 2 different side lengths. This is a rectangle. This is round. It's flat. It's a circle. Right here, you have 2 right angles, which means these sides are parallel, and if these opposite sides are the same, this is a parallelogram. Again, 2 right angles means these are parallel. These are not the same. These are not the same. This is a trapezoid. Then we start moving into the 3-dimensional objects. This one is technically a triangular prism. I'll get into why this big B is here, but for now we'll call this the triangular prism. When you get into 3-dimensional shapes, a lot of things are prisms, and you call them that based on what their base is. So if this base is a triangle, it's a triangular prism. What do we think this is? It's 3 dimensions. It's got this shape on the top and bottom. Yep, rectangular prism. Right here, a 3-dimensional thing with a circle on the top and bottom. You might think it's a circular prism, but actually it's got a more fun name than that. It is a cylinder. Right here, 3-dimensional round thing is a sphere. This thing that's got a triangle kind of top looking thing with a circle on the bottom is a cone. And this, because it's got a square base, is a square pyramid. And even more specific, which maybe you'll need it, maybe you won't, because of all these right angles, this would be considered a right square pyramid. More often than not, you might just hear it being called a pyramid, but if you look at the base, that tells you what type of pyramid it is. And if you know you have a right angle going straight up to the top point, that will make it a right square pyramid. I'll give you a sec to copy these down. Okay. Now that we have names for everything, we need to start breaking down what all these formulas are. And your biggest hint is right here. This tiny little box that's hidden away at the bottom has almost all the abbreviations you will need. For example, let's just start highlighting stuff. A lot of times when you're dealing with 2-dimensional things, you're going to get the big capital A. That is our area. That is the space something takes up in 2 dimensions. Other things that you will be looking for, lowercase p shows up a few times all over the place. That's going to be perimeter. Perimeter is the distance around a shape. It's straight lines, and you always start and end at the same spot. There's a perimeter. When you're talking in these 3-dimensional things, perimeter is going to be the perimeter of your base. So there or here. When you are looking at other things in 2 dimensions, C is going to be your circumference. That's like a round perimeter. It's the distance around a circle. Then you'll notice a bunch of capital A's here with stuff in front of it. We have LA, not to be confused with Los Angeles. This is lateral area. And then we've got SA, which is surface area. I'm going to start with surface area first because that's the easier one to know. Surface area, in 1 dimension, there is no surface area because you can only take up space in this flat plane, just inside your rectangle. But if we have a 3-dimensional shape, you count up the area on the bottom, on each of the sides, including the back, and the top. That is surface area. Now, lateral area, lateral, just think along like the sides, right? Instead of doing everything, lateral area only includes everything that is not a base. So over here on this cylinder, you would take out the top, you would take out the bottom, and it would just be the area around this cylinder. For this cone, you ignore the bottom, it would just be up top, everything up top. So you always, whenever you have lateral area, remove your bases. Some things, like this, have 2 bases. This has 2 bases. Some only have 1, in the example of a cone and a pyramid. We have volume as well. This is space you take up in 3 dimensions. You will never have volume for any of these flat shapes. They've got to be 3-dimensional. It's just imagine what would happen if you filled it up with water or filled it up with anything, right? How much would it take to fill it up? So that's everything inside if you filled up all of your shapes. As you can see, all the ones I crossed out do not have volume. Everything here does. Now that covers everything in this table, but there are some things that have not been labeled. Take a second, see if you can find some of these variables that I have not talked about. Right off the bat, we can look at the very first one, H. H shows up a lot. You've used H before. It's talking about height. It's how tall something is, whether it's flat in 2 dimensions or in 3 dimensions. Lots of things use height. And even though it's not down here, all of your pictures have it labeled as to where it is. Another one, lowercase b, not to be confused with big B. Big B is always the area of a base. Lowercase b is just the length of the base, or the bottom, what you're looking at. You have the base here, 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 and because you have 2 different length bases here, you have base 1 and base 2. R, which you see in circles a lot, is your radius. You're only going to see that in round shapes. Lastly, L. L, for whatever reason, you should write this down because L is an important one, and it's not really labeled here. L is slant height. So if H is height, L is like the diagonal height. You'll see this in pointy shapes, namely the cone and the pyramid. Sometimes it'll be given to you, sometimes you will have to find it, and I'll show you how to do that soon. But at this point, I think you guys have seen everything you were looking for. You should have all the names written down, and if any of these variables don't make sense, make a note over here. You know, H is height. L and W, in case you didn't see me say this, in case, actually I didn't even say it. L is your length, W is your width. You see that in squares, in rectangles. But everything else you've seen so far. I'm going to keep referring back to this page because this is going to tell us everything we need to know. Other things you need to think about. They're not always going to say, find the volume of this, find the area or surface area or lateral area of this. Sometimes they will, but sometimes they'll try and throw you off by saying other words that mean volume, things like fill, Like how much space would it take to fill this up? Things for area. Maybe you're like painting the sides of something. Anytime you're talking about just flat sides, you're usually dealing with area. And almost always when you're dealing with 3 dimensions, meaning how much space something takes up, you will be working with volume. So space. I'm not going to write a long list here because sometimes they can use things that you've never seen before. But again, volume, 3D. Taking up space in all directions. Area is usually going to be flat or 2-dimensional. Now, if you have surface area or lateral area, you can use that on a 3D figure, but realize you're not looking at what's inside the shape. You are looking at the flat sides or the curved sides that make up the shape. Let's try some problems. First thing I want you to do, don't read anything. Look at what we have. Look at the shape. Go back to your formula sheet. We will be working with this. What are we going to use? I don't know, it doesn't matter. But the first thing you have to do is ignore everything else because there's a ton of stuff on this page. And if you sit here and just stare at it, you might zone out and completely forget what you're doing. But as soon as you see this pyramid, you should be like, oh, hey, we're working with a pyramid here. And even now it says it's a rectangular pyramid. I know I said earlier that what we had was a square pyramid, but all the formulas still work. Now, luckily, we have been told exactly what we want. We want the volume of the pyramid. So right now, you go back to your formula sheet, you look up, and you say, okay, I need volume. Look here, volume is V. We need this right here. Volume equals 1/3 capital B H. Again, capital B is the area of the base. So let's write that down. 1/3 times capital B times H. The 1/3 is not going to change, so if we're solving for volume, I'm going to write that down. Area of the base. Here's our base. It says it's a rectangular prism. So if we need to find that area, we can use our formula sheet. We know we have a length of 12 and a width of 9. So let's go back. If we need to replace this B with the area of that rectangle, let's go find out what the area of a rectangle is. Right here. It is length times width. So here's our length, here's our width. I'm just going to put everything in parentheses. This capital B has been replaced. Let me change colors so we can see this even better. B, oh my God, I can't even highlight this morning. Pardon me. Here's our B, our area. Length times width. That covers B. We still need H. Our 1/3 is already taken care of. So switching over to the H, we need the height of this shape. And I'm going to clear this out so we can see exactly what we are looking at. From the base to the top, that's our height. We actually have it as well. It is 8, so plug it in. Now, go to your calculator. And once you have your calculator, you're going to plug this in. Now, I realize that I didn't put the 1/3 in parentheses, but of all of these numbers, fractions are always the most important to put in parentheses to make sure that you are plugging things in correctly. So 1/3 times 12 times 9 times 8. You're more than welcome to put the 12, the 9, and the 8 in parentheses, but this will also work. Again, fractions must be in parentheses. Hit enter. 288. Let me close this down. So our volume equals 288. Now, we started with units. This is centimeters, so we have to put centimeters. And whenever we're dealing with volume, that's 3-dimensional, so we use centimeters cubed, meaning it's a centimeter in 3 different directions. I was going to draw a cube, but I'll save you the horror of looking at my terrible drawing. 3 dimensions, cubed units. So, right here, H. Now here's a super important question. I hope you have a little bit of space left over because we need to answer this sometimes. I'm going to clear this out. Remember, H was our answer, 288. If you ever need the slant height, that's this right here. I'm going to point out something super important that maybe you see, maybe you don't. This is a right triangle. Pythagorean theorem is one of the most important things that you cannot forget. So maybe, if we look back at the formula sheet, maybe sometimes it'll ask you to find either the lateral area or the surface area, in which case you need that slant height. If you were given the problem just like this, you are not given it directly. You have to figure it out. So take a little cross section, meaning just redraw this triangle. Label what you know. You know the height for sure is 8 centimeters. You'd be looking for L, the slant height. But down here, notice this bottom part of the base does not go the full direction. In fact, it's only going to go halfway. So half of 12 gives you 6. From here, you would do 6 squared plus 8 squared equals L squared. I know when you add those up, you get 100 equal to L squared, which means if you needed it, the slant height for this would be 10. Oh, excuse me, 10 centimeters. Now, do you need this every time? No. Do you need to know how to find it in case you do need it? Absolutely. And again, Pythagorean theorem. Let's look down to this next one. We've got a goofy looking shape, right? We have a right circular cylinder and a right circular cone. So we've got a cylinder, we've got a cone. We need to find the surface area of this container. I'm going to give you a word of caution. Yes, there is a cylinder. Yes, there is a cone. That does not mean we are finding the surface area for both. Here's why. Surface area is anything that's on the outside. So if we look at this cone, is everything touching the outside? No, our base of the cone is not. In fact, just the top part is what we need. So if we remove the base and we're looking for area, what are we trying to find? That's right, the lateral area. And I'm going to try and draw a cone. Please be kind. All right, so we need the lateral area of a cone. That takes care of the top part. Now again, if we look at this cylinder, is everything touching the outside? If it is, we can just find its surface area. But it's not. Again, this base, this top circle, is not touching the outside. That's on the inside of our shape. So we can't just find the lateral area. Or excuse me, the surface area. We do have to find the lateral area. That's everything minus the bases. So we need to find the lateral area of a cylinder. The last thing we're going to have to find is the very bottom. That is touching the outside. And because we found the lateral area, we removed both bases, but we still need one of them. So we look at this. That is a circle. We need to find the area of the circle on the bottom. When we find all three of these things, we add them together, and we're looking for whatever is the closest. So I'm going to go back and copy down a few formulas. Lateral area for a cone, right here. Pi times r times L. Lateral area for a cylinder, right here. 2 pi r h. Area of a circle, right here. Pi r squared. This is going to be really easy. You guys ready? Notice in all three of these we need the radius. If we look down here at the bottom, we don't have the radius. We have something that goes from one side of the circle all the way across to the other. What is that? 24 is our diameter. What do you do to a diameter to get the radius? You cut it in half. So 12 is a super important number we need for this. That's going to go here and here and here. Pi is a button on your calculator, which I'll show you in just a minute. L is the slant height of the cone. Do we have that? Yep, 13 right here. That's the slant height of the cone. 13 equals L. And lastly, we need the height of the cylinder, which is right here, 10. I like writing these notes to myself off to the side because that helps keep me organized. So what I'm going to do right now is pull up my calculator. I hope you guys do the same. And since we have R, L, and H, those are the only variables we need, I know we have to plug all of these in and add them together. So I'm just going to do that right now. The lateral area of the cone, pi, which is right here in blue if you've never seen that before. So hit second and then the caret button. You could plug in 3.14, but this gives you a ton more digits and it's a lot more precise. Pi times the radius, which is 12, times the slant height, L, which is 13. That takes care of the first part. Plus 2 pi times your radius times your height plus pi r squared. Pi times your radius is 12 squared. Hit enter. We get about 1696 point, we'll call it 5. Why am I rounding it? Because the word here says what is the closest, meaning what is approximately this. Well, it's not 490, it's not 754. This is up there, but 1696 is probably the closest to 1696 point something. D is the answer for that one. Again, whenever you have multiple shapes, break it down and pay close attention to what you're looking for. Sometimes you will not be given a picture. And if you're terrible at drawing like me, that's perfectly fine. You just need to visualize what's happening. You have a fish tank, which is in the shape of a rectangular prism. I'm actually going to go back right now. Well, actually, let's see what we need before we go back to the formula sheet. You've got your length, your width, and your height listed here. It's asking for the volume, how much water will it take to fill up the tank, but it's not asking if it's full. I'm going to come back to this at the very, very end. This is an important step, but let's backtrack. We need the volume of a rectangular prism. Let me clear all this out. A rectangular prism is kind of like a box or a cube. And here's our volume. This one's really easy. It's length times width times height. So volume equals length times width times height. Let's do that. If we want the entire volume, all we have to do is just do 20 times 10 times 12. But I say again, that important step of we don't want all of the volume. We want 4/5 of it. If you ever need a part of what you're looking for, meaning you're starting with the volume, but you only want some of it, take whatever that fraction is, whatever that percent is, and multiply it at the very front. 4/5 of, this is volume, length times width times height, 4/5 of that will give us our answer. So, again, fractions go in parentheses. That's the most important thing to remember. 4/5 times 20 times 10 times 12. 1,920 inches cubed, because again, we're volume. Now, it could be written like this, IN with a 3 exponent, or if it's inches cubed, it could be cubic inches, or if they're feeling really lazy, CU, cubic, IN, inches is the shortcut for that. So again, 1920, 1920. Here, we have the volume of a cube being 64 cubic centimeters. We are given the volume. It asks, what is the surface area? So let's go back. we don't have a cube on here, but a cube is just a very specific rectangular prism. If you've never seen a cube or heard of a cube, it's a rectangular prism with squares on all of the sides. Yeah, that's a cube. But the important thing to know is if all of the sides are the same, that means length and width and height are all of the same. So if you pick one side, you have a side here, a side here, a side there. Length times width times height for a cube, it means the volume is just the side length cubed. Now, the surface area looks really complicated because you've got length times height, and width times height. But again, it's a cube. If all of the sides are the same, that means all of these variables are the same. So, surface area of a cube, which we're going to need in a second, is 2 times the length times the width. If they're the same, that's just s times s. So it's equal to 2s squared plus, again, length, height, width, they're all the same. In fact, all three of these are going to be 2s squared. If all of your sides are the same, there's no need to give them different names. 2 plus 2 plus 2 gives you 6 times s squared. So I'm going to take the s cubed for volume and the 6x squared for surface area and use that. Remember, this is where we want to end up. Can't answer that until we figure out what S is. So, we already know the volume. It's been given to us. It's 64. 64 equals S cubed. If we can solve for S, we're in great shape. Well, just like if you have S squared equals 36 and you take the square root to undo that, when you have a cube, you take the cube root to undo that. Let's go back to our calculator. If you forgot where that was from earlier in the year, you hit Math, and then right here, what looks like a square root with a 3 in front of it, number 4, is actually the cube root. The cube root of 64 will give us our side length. That is 4. So coming back here, once you take the cube root, little 3, of both sides, you find out that 4 centimeters, is your side length. So we take that, plug it in, and your surface area equals 6 times 4, our side length squared. $96. Got to remember our units, centimeters. And because it's area, that's 2 dimensions, it is square centimeters, or centimeters squared. One more. This problem takes a circle and breaks it into a shaded region. We want the area of the shaded region. Now, do we want the whole area of the circle? No, but we do want area, so I'm going to start there. Let's go back. Area of a circle, right here, pi r squared. Area equals pi r squared. Now this problem is very similar to one we've already done. This problem, where we didn't want the entire volume, we wanted a percentage, a part of the volume. We wanted 4/5. In this one, we knew exactly how much we wanted. Here, we have to figure out what fraction, what percentage we want. Believe it or not, this is really, really easy to do. Let's start by just plugging in what we know. If we wanted the whole area, we don't, but if we did, we would plug it in and do pi times our radius. Radius is from the center to any point on the circle. For this one, it is 5 times 5 squared. That's a 5. That might get confused for an S, but that's 5 squared. Now, how much of this do we want? In this shaded section, I see 130 degrees. Always take what you want and put that on the top of the fraction. Below that, you always put the entire amount of whatever you're talking about. In circles, the entire circle that you're talking about is 360 degrees. So if you only want 130 out of 360 degrees, this is the fraction that you want. You could go back and simplify this, but why? You're just about to plug it into your calculator anyway. So, big parenthesis, because it's a fraction, 130 divided by 360, close your parenthesis, times pi times 5 squared. 28.36-ish. We're dealing with centimeters, it's area, so it is squared. 28.36. It's looking for what is the closest, so don't freak out when you don't see the decimal. The closest thing to 28.36, I would say, is 28. Again, folks, I'm going to run this down in like 30 seconds of what you need to do. First thing you do, use your eyes. If you've got a picture, go to your formula sheet and find the thing you are looking at. If there's multiple shapes put together, like in this problem, find everything you might need. Step 2, break it down into what you want. Is it volume? Is it surface area? Is it just a length? Maybe you just need the slant height. Whatever it's asking you for, find a formula that either gives you the surface area or includes the slant height to help you find it. And don't forget, you can always make a right triangle to find slant height. Last, find all the pieces you need and then make your calculator do the work. Don't let the formula sheet scare you. This is such a powerful tool. It gives you so much information that be happy you don't have to memorize all this. But if you don't know how to use it, it's very difficult. It can be intimidating, but try the next few problems. I guarantee you, you will do just fine. Good luck.